You bow your heads, please.
Dear Heavenly Father, thank you this day. Thank you that we can all come to heed and learn.
Yes.
Thank you for Miss Frades who can come all the way down here every day and teach us. I pray that we all learn something useful today that we will use in our lives. I pray that we all have a good time. Amen.
Amen. I like it. Good prayer. Thank you, sir. Afterwards, I feel like, hut, go, right? Okay. First, for those of you that don't know me, because there's about half of you that are new students, my name is Katie Frades. You're supposed to call me Mrs. Frades. It's just a respect thing. And but your moms can call me Katie, okay? I get a lot of moms that write Mrs. Frades, and that freaks me out. So, but to the students, I'm Mrs. Frades, okay? And I am a scientist by degree. I am a disciple of Jesus Christ, first and foremost. I'm a homeschool mom. So I understand how that is, and I'm a scientist by degree. I went to Auburn University and the University of Florida, and my degree is in cell biology. I teach science because that's what God's called me to. You already know I teach creation science because you guys have all suffered through the 3 classes on creation science that was the foundation that we need, because then we're going to build on that foundation. Okay, so hopefully everybody's done that. The required textbook is the 2nd edition of the Exploring Creation with Physical Science. And so we will, in general, work through 1 module every 2 weeks. Now I say in general because we'll alter that one time. One of the chapters we'll do in 1 week, because then we're going to spend 3 weeks on the last chapter, because we're going to have some fun with creation astronomy, because it is just so cool to study the stars and learn all about that stuff. And so we'll spend a little extra time there, okay? So we'll take it out of the chapter that's about magnets and electricity, because we can just bop through that really easily. It's not a big deal. So in general, we'll spend 2 weeks on a chapter. On my syllabus, which hopefully you guys all printed out the syllabus already, and it's in the front of your notebook. Okay, on that syllabus where it says Prep for Class 1, I know I'm different than everybody else and I'm sorry, but where it says Prep for Class 1, that means it's the work you do to prepare for Class 1. And so after today, you will do Prep for Class 2. And so you will finish Module 1. When you go home, you will actually finish Module 1, and you will do the study guide. As you read through this, why it says read and complete, you are supposed to read everything in the text, including the experiments. Even though you're not going to do the experiments at home, you're supposed to read them. And if you guys have done your reading, you already know why. Because then he goes on and explains the experiment, and he builds on it, doesn't he? So you have to read the experiments as you read this stuff. And so you read the experiments, you answer the on your own questions. The answers to the on your own questions are at the back of each chapter. And it's important that you check your work as you go, because practice doesn't make perfect. Perfect practice makes perfect. And there is going to be math in this class in several chapters. And so it's very, very important that you have the answers available to you so that as you do it, you can check the math as you go along. This is your first high school science for many of you. Make sure that you use a calculator. You are not allowed to do the math by hand. Are we clear? I don't care if you can. You're not allowed. But you do have to write out all your work. And I don't care if you can do it in your head. Not in this class. You have to write out your work. You have to write out the steps that you're doing, because the steps that you're learning here, you will continue to use all the way through chemistry and physics. And so it's more important to me that you learn the process than that you know how to do the math. Are we clear on that? So it's very important to me that you write it all down and I can see what's going on so that I can make sure that you're doing it. Plus, when you bring tests to me, if you have one little mistake but you've written everything down, I can give you most of the credit. That's always a nice thing, right? Okay, after you read the chapter and you do the best you can at answering the study guide questions, so that would be finished next week. For your homework next week, you'll finish the chapter, or you'll do the best you can at answering the study guide questions. The answers to the study guide are in the Solutions and Test Manual book, so you would check your answers there, and we will go over them in class. If you look at it and go, I just don't get that, it's okay. We are going to go over it in class together before you have to take your test, okay? And then you're going to go ahead after next week's class, you're going to go ahead and study for the test, and then I would suggest you take it shortly after the class, maybe the next day or so. Take the test, and then you'll have the rest of the week to prepare for the next module. or the next homework assignment, whatever that is. Now, we will grade the test the beginning of the next class that we get together. So that means the beginning of the third week of class, after we pray, the very first thing we're going to do is grade the test. And that means that even if you grade your test at home because you're like me and you just can't stand it, you have to know whether you did well or not, and I understand that. Even if you do that, you still need to bring the test with you because we are going to go over them together. And if you don't bring it, it really throws off our whole rhythm thing as we go through the test together. So please bring it with you. Also, I may give you partial credit that your mom may not know that you should get partial credit for something, and I may give you partial credit because I can see what you did and then you just misdid it on your calculator or something. So once again, it's very important that you write everything down for me so that I can see it and give you partial credit. Especially these tests, some of these tests he only has 10 or 15 questions on, and if there's 10 questions, you do the math real quick, that means every question's worth 10 points. You want to get partial credit. You don't want to just go, and there goes 10 points out of 100. That can add up really fast, can't it? So you want to get as much partial credit as you can. That also means don't leave anything blank. Answer every question to the best of your ability. Guess, do the best you can, but don't leave it blank, okay? I have been able to find proper answers in lots of explanation when students weren't sure and they go, well, I remember she said this, and they wrote everything down, and if I can find the answer and all that, I'm going to give you credit, okay? So also, some of the stuff that I'll say won't be exactly what the book says because I'm a scientist, so I don't feel like I have to do exactly what they say, and therefore your answer might be right, but if your mom's grading your test, she might not know that because she won't know what I said in class. So that's why it's important for you to bring your tests also, okay? So there's a lot of reasons to bring your tests, but you will take those at home. And if you're taking the class for, especially if you're doing it for the honors credit, you want to make sure that you don't use the book while you take your test. There are vocabulary words in all of these high school classes. When you're taking high school science with me, I do not want you to memorize the book's definition. I want you to come up with the shortest logical definition in your own words that you can, because I want you to not just memorize what the book says and 3 weeks later you have no idea what it said, which is usually what happens. I want you to have a short definition that you can keep in your mind and you can actually keep it and use it. That's the idea. So come up with the shortest working definitions you can. I will make some suggestions on what some short working definitions are that other students have told me through the years, okay? You want to keep track of your homework, your tests, and your lab write-ups in a notebook because this is your first high school science with lab. And when you go to apply for colleges, some of them will say, prove to me that that was a high school science with lab. And if you produce your notebook for them and they can see all that work in the lab write-ups, they will give you credit. I've had that happen to a few students. So it's important that you keep that. When you do the lab write-ups, you noticed that there were 4 points to a lab write-up. You noticed that in your syllabus. Did everybody read that? Okay, so you had the purpose, and the purpose is usually found in the beginning of the lab. If you'll turn, I just want to show you so you make sure you know, but if you turn to that first lab, turn to page 2. On page 2 in the introduction, it actually explains to you why you're doing the lab. And you're learning about atoms and molecules, aren't you? Now, honestly, if you look at the title of the lab is called Atoms and Molecules, and if you ever are short for not knowing why you're doing what you're doing, put learning about and whatever is the title, and you're probably pretty close to what the purpose should be. Just a heads up, okay? Don't make it too long. You're not writing a book here. It's a science class. Then for your procedure, I want you to keep it as short as possible, but you're trying to tell somebody else how they would do it. And you want to do it in a step-by-step, as short as possible, you know, so here you would say, cup of water with a teaspoon of baking soda, 9-volt battery with wires attached to it, taped down. Okay, something, keep it short, don't kill yourself, okay? Then the third part is your observations. Now when I tell you to prep for a lab, you're going to do these 2 parts before you come into class. And then when you come into class, you're going to do part 3. We're going to do the observations, which we are going to do a lab today. So you're going to do those observations, and you're going to write these observations down, and we'll go through them together. And then when you get home, you're going to finish the lab by doing the conclusion. And the conclusion is basically what you learned in the lab. So why you did the lab and what you learned. And why you did it, don't say because Mrs. Frady's made me, okay? No, you're doing the lab because you're trying, it'll reflect something in the purpose. Like we are trying to learn about atoms and molecules, and then you want to state a fact that you learned about atoms or molecules. You know, what did you learn about atoms and molecules? And he'll usually describe for you what you're trying to do after the lab. Your conclusion will usually be found in a couple paragraphs after the lab in the text. Okay? And so you're going to connect that fact with your observations. Now, heads up, sometimes labs don't work. So you may want to write down, well, this is the fact I was supposed to learn, but the lab didn't work out just that way. And that would be the place to write that. Okay? So, but we'll go through it, and that's the benefit of having several people doing it. So that's how the labs work. So let's go ahead, and if you don't have it open already, go ahead and open your textbook to, let's start by starting with the experiment, because it's supposed to sit for 10 minutes, so we probably ought to get it started. You already have water in a cup with baking soda. We have a cup of water. And we are going to add a heaping teaspoon of baking soda and stir it up really well. My husband prepares these for the classes so that we don't have to go through all that in class. It is a 9-volt battery, and it has 2 wires attached to it that have been stripped on the ends. This saves us some class time. Notice that they are copper colored because it's copper wire. Then we are going to stick it down in there. Can you see the bubbles? There's bubbles coming up here. And here, I'm going to turn this so that you can see the end of both wires. And if you'll notice, both wires are bubbling. Now this one is bubbling more than that one. I don't know if you can see that. Aha, very good. Observation, you made one, very good. Now, let's talk about this because we're supposed to let it go for 10 minutes, so we're going to talk about it while we're letting it go. Wait, what was your name? You're going to have to help me.
Molly.
Molly, yes, Molly.
How do you know which side is the positive and
I'm going to tell you in just a minute because you're right. It's all taped up, like, woo, taped up. Okay. My husband builds these for you because if I had you do all this that it talks about in this lab, that's all we do today. Okay, so, and I'm going to tell you right now, my husband hates doing this, but he does it for you, which means he does it for me. So, but this way you actually have a chance to see the lab. So that's what we're doing. In this lab, once again, if you turn to page 2 in the introduction, it tells you that we're learning about atoms and molecules, and that they're too small for us to see them, and so we have to learn things about them by doing indirect observations, by doing experiments. And we are learning the basics, and that's why this chapter is called The Basics, and we're starting with the basics on learning about, once again, atoms and molecules. Now, what is water made up of? Even if you've never studied science, you know what water is, chemical formula is. What is it? Good. Water is H2o. You have heard that before. Water is made up of 2 hydrogens attached to an oxygen. That's the molecule that makes up water. Now, the hydrogens are atoms, and the oxygen is an atom, and when they get together, they make a molecule. And so when we put the battery attached to the wires into the water is being electrically broken down by the battery into hydrogen gas and oxygen gas, and those are the bubbles you're seeing. You're seeing actually hydrogen gas and oxygen gas because we're electrically splitting the water molecules. Now, why we're doing this is this. Rachel, right, already said that she sees the water turning blue. And some of the others of you, I can see your water's turning blue. And maybe if you had, I can start to see that's turning blue. Okay, so that's your first observation. You should write down that something's happening in there because now your water is turning blue. You should also write the observation that, what other thing are you seeing there?
The water is bubbling.
Thank you very much. The wire is bubbling, absolutely. What was your name again?
Lydia.
Lydia, thank you, Lydia. The wire is bubbling. And so that tells me something's happening. The water has changed colors. That tells me something's happening, right? If you would, well, we'll wait 5 more minutes because that's when the 10 minutes will be over. Let's, if you will, with me, look on page 3, and it defines for us an atom. And it says an atom is the smallest chemical unit of matter. I remember in the first edition of this book, because this is the second edition, it said that, yeah, that's how long I've been teaching these books. It said that an atom was the smallest stable unit in creation. And I like that because you can break an atom down into its particles, into the nucleus of the atom, which is made up of protons and neutrons, and then electrons buzzing around the outside edge. But they're not stable. I mean, how do you make a nuclear bomb? By dealing with the nucleus of the atom. And how do you get electricity? By dealing with the electrons, neither of which are real stable. But the smallest chemical unit of matter will do, and that's how it's defined there. And they're very, very small. No one has ever seen an atom. No one has ever seen a molecule, not regular molecules. Some molecules of life, like the DNA molecule, can be so large that we can see them under the microscope, but they're still very, very small, even though they are huge molecules made up of thousands of atoms. They still are very hard to see, even with a microscope. So in general, could honestly say that people cannot see atoms or molecules, okay? Now, if you'll flip the page, it defines what a molecule is. And a molecule is actually when 2 or more atoms are chemically bound together. And that includes 2 of the same kind. When that hydrogen gas is coming out of there because water has broken down, it ends up being hydrogen, which is this, 2 hydrogens attached to each other, and oxygen, which is this, which is 2 oxygens attached to one another. And so actually the hydrogen and the oxygen coming off of there is still molecules. They're just different molecules than the water molecule. Okay? The only way it wouldn't be a molecule, it would be an atom, is if they weren't chemically bound together. And the wire is made up of copper, which is a whole bunch of copper atoms. Those are atoms. That's not a molecule. The copper is just an element. It's made up of a whole bunch of copper atoms. Does that make sense to everybody? So as soon as atoms combine together with other atoms, even if it's the same kind of atom, as soon as one atom has combined itself to another atom chemically, it is no longer an atom, it's a molecule. So far, so good? Okay. Now I want you to pull your battery out. And I want you to look at the 2 ends. Don't put it back in. Just pull it out and let's end this now. And let's look at the 2 ends. What do you see on one end? Okay. Us girls would say it's teal or turquoise, you know, whatever. Blue. You can say it's green. I don't care. But the point is, and you don't put them back in. Let's leave them out now. So your last observation, so far we've seen bubbles. We've seen that the water's turned blue. And we've seen that one of the 2 wires has turned a blue or turquoise or green color. I don't care. You pick the color that you want to call it. Now I'm going to tell you so you don't have to rip these apart because it's very difficult. It is the positive side of the battery that the blue one is on. So you need to write that down because he asked that question. It is, and I ripped one apart at home just so I could tell you that. Okay? So it is the positive side of the battery that is actually, and then I found it in the text. It was in the text. But I did rip one apart just to see, and then I found it in there. Okay. Now, what are we supposed to have seen with this experiment? What we saw was that atoms have different characteristic properties than molecules. That's what you're trying to see, or that atoms are different than molecules. You could just write that if you wanted to. And the reason we say that is this. Water is a liquid that puts out fires, right? But if you break the water down and make hydrogen gas is an explosive gas. It's not a liquid anymore, and it doesn't put out fires anymore. Matter of fact, it's just explosive. Oxygen is a gas that fire needs to burn. But this puts out fires. What I'm showing you is that every individual molecule has very different, very unique characteristic properties. As soon as you add anything to it, it actually becomes a totally different molecule. Let me show you. We're going to add one more oxygen to this molecule. So now this molecule is formed. These are real molecules. Okay? That molecule is called ozone. This molecule, if you don't have it, you die. Because you need oxygen to survive. That's why we breathe, right? If you breathe ozone, you die. So without this one, you die, but with this one, you die. Huh? Well, because now it's poisonous. It's totally different. I got another one for you. If you have an iron nail, iron is magnetic. You can get it with an iron, with a magnet. It's very strong, right? But if you combine that nail, that iron nail, with water and air, it rusts, which makes iron oxide. Iron oxide is no longer magnetic, will not be picked up with a magnet, and you can put your finger right through it. Rust. New molecule. It's different. Okay? So no matter what you attach, I mean, now does God have a Lego set or what? Serious stuff. So out of 186 Lego blocks that God has in his kit, okay, if God snaps on one new thing, even if it's the same thing over and over again, if he snaps on one new thing, it's totally different. Totally new characteristic properties. Pretty neat, huh? So molecules, actually, we're going to define that as two or more atoms, and they have unique properties. Okay? Now, some of you are real thinkers, and you're going to overthink things. And when you, well, I'll get to that question in a minute, and I'll come back to that. Look on figure 1.1. And you see on the left-hand side, those individual hydrogens and oxygens are not attached to one another. Therefore, those are atoms. Whereas on the right-hand side, you see that the oxygen is attached to the hydrogen. Therefore, those are molecules. Okay? And I already told you, if you have a whole bunch of atoms in one place, that's called an element. If you have a whole bunch of molecules in one place, like distilled water is supposed to just be water molecules. That's it. That's called a compound. Okay? The difference is spring water has other things mixed in it. That's the spring water, because it's got minerals in it, or mineral water. And then a mixture would be like your spring water, where you have different things in there together. And he used the example of wood, which I found rather interesting. Okay, let's look on page 6 at 1.1. On your own, 1.1. It says a molecule is broken down into its constituent atoms. Do these atoms have the same properties as the molecule?
No.
Well, no, thank you. No, they don't. Assume that they don't. Because as soon as you make a molecule, they have different characteristic properties than the atoms that make them up. That word constituent, you might not be familiar with, and while I'm thinking of it, let me just say this. If you see words on your test that you don't know what they mean, and they're not vocabulary words, go ask your parent what the word is, or get a dictionary and look it up. I don't want you missing a test question because there was another word in there that you didn't know what it meant, okay? It happens in biology. I just went through that explanation in biology too. So just for the heads up, don't miss something. Vocabulary words you're not supposed to go back and look up while you're taking your test. But other words, you feel free to, okay? Because did everybody here know what constituent meant? Good, some of you did, some of you didn't, and I understand that. So constituent is the things that make it up. Let's look at 1.2. When salt is dissolved in water, it actually breaks down into two different substances. Is salt a compound of atoms or molecules?
Molecules.
It's made up of molecules because I can break it down into atoms, but there are some students that will look at that and go, but wait a minute, molecules are made up of atoms too. Don't overthink it. You'll get in trouble. I'm one of those people. I overthink things. I have learned how to answer the test questions the way whoever wrote the test wants me to answer, because I get in trouble that way. So if you're like me and you overthink things, just stop and answer the question they want so you don't get in trouble. You'll even get in trouble in college for that. It's sad, but it's true. So anyway, and then other things, they'll go, well, why didn't you think of that? You're supposed to know it. And I'm like, wait. If I did that before, I'd get in trouble, you know? So, all right. Below that, you have a picture of what some people believe is a electron microscope, or electron micrograph of what is believed to be nickel foil. And he tells us here that if anybody tells you that you've ever seen an atom, tell them that's not true. Because what the electron microscope does, a regular microscope actually bounces light off of something back to your eye, so you're actually seeing it. An electron microscope shoots a beam of electrons back into the computer, and then it actually has to read how the electrical changes were as the electrons bounced back to the computer, and then it actually uses a quantum mechanical, a very difficult set of mathematics, calculations to go through, and then it graphs what it thinks was there by those slight variations in the electrical charges that came back. And then it gives you a picture. And it colorizes it for you so you can see what's in the picture. Okay? Now, he says here there's a bunch of ifs involved. And if those things are correct, then this might be a picture of nickel foil. But he says, but the point is that there are ifs involved, so you don't know. He also says, Jay Wiles, who has a PhD in chemistry, and I have a lot of respect for, he also says, and he's the author of the book, in case I missed that part. He also says, though, he believes that's probably what nickel really looks like. But the point is that nobody's ever really seen an atom. So he just wants to be honest. Okay? All right, then we get to measurements in units. And you've probably started on these in math. You've converted inches to miles, maybe, at some point in time. Or seconds to hours, or vice versa. Okay, that's what we're going to be learning about here. So first we want to learn about our units. Measurements in units. He tells us how very important that the units are. And he gives you an example of if somebody, I can give you an example that I know you'd appreciate. If you were going, let's say one of you were going to babysit for somebody. And you were going to babysit and they told you, we will pay you $20 an hour. And you babysat for 4 hours, so you were expecting $80. And they came home and gave you 80 cents. You'd be mad, wouldn't you? And the reason is, you were expecting dollars, but if they didn't say the unit, you don't know, and they could have meant 20 pennies an hour, right? The units become very, very important because without them, we can have major disasters. And it talked here about how that plane ran out of fuel, excuse me, because one group was using the metric system and one group was using the English system, and they didn't write down their units, and so they didn't know they were using different types of systems, and therefore the plane ran out of fuel. That's very dangerous, isn't it? So these can become really bad problems for people. Now in class, what do you need to know? You need to know that if you don't put units next to an answer, the answer is incorrect even if the number is correct. Because a number without a unit is incorrect. I'm going to tell you that right now. Okay? Okay. So on the next page, on page 8, he gets into the metric system. Now, we use the metric system in science because the metric system is used by scientists all over the world. Here in the United States, we use the English system for normal stuff. But in science, even in the United States, we use the metric system. That's what's used. And I'm going to tell you that the reason I'm glad that scientists use the metric system is because it is so much easier to get between things, because all you have to do is multiply or divide by 10. And I don't know about you, but I can multiply and divide by 10. It's so easy. You just move zeros around, right? Whereas, if you were to ask me how many inches there were in a mile, ouch. I can't just move zeros around, can I? I got to move all sorts of other weird numbers around. So it's just easier. Even in the kitchen, have you ever had to deal with how many tablespoons are in a gallon? Or shoot, even how many cups are in a gallon? Everything is different each way. I think there's 12 tablespoons in a cup. 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon. Who came up with that? Why did it just jump like that? You know what I mean? So, or how many ounces? So it gets to be rather difficult, and that's why, and that's the English system, and I'm not saying I'm against it because that's a system I know, but the metric system is used by scientists all over the world, and so scientific data will be listed in the metric because that is what is used by scientists everywhere. Okay? And so on page 9, you have to memorize what the basic units are for how we measure matter in the metric and the English system. Now, matter is anything that has mass and takes up space. It's made up of molecules and atoms, one or the other, and we need to be able to measure that. If we're measuring how much matter is in something, we can usually do that by measuring the mass. The mass is different than the weight. And he explained that to you, didn't he? That was in this week's reading, right? Yes. Wasn't it in it? Okay. The mass is different than the weight. Did he explain this in this book, or was it in the chemistry book that I saw it? He did explain it in this book. Okay. The mass is like if I stand on my scale, and I get depressed, okay, but I stand on my scale, it'll say something, and then if I took my scale and went to the moon and stepped on my scale, it would say that I weigh a whole lot less than what it said on planet Earth. Weight is different than mass in that weight is how much the gravitational pull pulls on something. So even though my weight was different here than it was on the moon, was my mass any different? No, my mass wasn't different because the mass is how much makes me up. To make my mass change, I have to exercise and eat properly, etc. Does that make sense? Okay, so mass and weight are different, and he tells us here that mass in the English system is called slugs. You know, like the little creature that comes out on the sidewalk after the rain, slug. And this is the only place you'll ever see this except for in physics. You'll see slugs again. In the English system, it's the unit for mass. I've never seen it outside of in this book or the physics book, honestly. Never seen it anyplace else. In the metric system, what do we use to measure mass? What is the basic unit? You have to know this. What is the basic unit to measure mass in the metric system?
Gram.
Very good. It's a gram. And a gram weighs approximately what a dollar bill weighs. Okay? Very light, isn't it? Okay. Once again, it's a slug in the English unit. And you know, he doesn't tell us what weighs a slug. I'll have to find out what weighs a slug so we can get an idea. Anyway, or what it's equivalent to. Then we get to distance. And what is the unit in English if you're measuring how tall we are? What would you measure us in? If you were to tell me how tall you are, you would give it to me in what unit? Feet, right, very good. You would say I'm 5'6" or whatever. So you'd give it to me in feet, and then you'd add on some inches there, right, if you weren't equal to something. Okay, so we would give it in feet, which would be the English system. And then what do we use in the metric system for distance? Look at the book. What do we use? Yes, ma'am. Meters, very good. And I want you to see the difference. I want you to see what a meter is. Okay, that's a meter. This is a meter stick. This is a meter. So you can get a feel. Do you see where this ends here? That's a yard. The yard ends right here. So see, the meter is slightly longer than the yard, isn't it? Okay? So that is the base unit for distance measurement in the metric system. Okay? Then we get to volume. And what is in the English system? If you've got a thing of milk, and it was a big thing of milk at the grocery store, what would it be?
Gallon.
A gallon, very good. You'd have a gallon of milk. You guys can just answer when I ask you. You don't have to raise your hands, all right? A gallon. That is the basic volume unit in the English system. What is the basic volume unit in the metric system?
A liter.
A liter. That's a liter beaker. Now, the reason we're more familiar with liters is because we get 2-liter bottles of soda and stuff like that, don't we? So we have some idea of what a liter looks like, but that is a liter. This beaker is a liter. So that is the volume, the basic volume unit that you would see. I want you to notice with time, thank you, Jesus, they're the same. Time is seconds, both places. So it's the same. We don't have to know a whole bunch there. Yay! Okay, turn the page. Now, it wants to tell us about manipulating the units. And what we're learning about is how to get from one unit to the other. And with the English units, it can get real dicey, depending on what you're doing. Like, let's say we have 30 minutes of class left, okay? And we want to know how many seconds we're still going to be here. All right? So with that, you'd have to go 30 minutes times line. This unit always goes down here, always. Because you want it to cancel, because this is really over 1, isn't it? So you want that to cancel. And then what we're trying to get to goes up here. Now we're trying to make a 1 here, because if I put the equal numbers on the top and on the bottom of a fraction, it's actually a 1, isn't it? Right? So I'm trying to multiply that by a 1 to see how many seconds it is. That's what I'm doing. And this way I know it's going to cancel, and I put what I want up here. Now, how many minutes or how many seconds are there in a minute? There are 60 seconds in 1 minute, aren't there? I don't want that to look like a 5. There you go. 60 seconds in 1 minute, right? So when I do that, I know I'm going to get 100, let's see, 1,800, right? Yep. Because that's 180, so it's 1,800 because there's 2 zeros. Shame on me, I shouldn't be doing this in my head. The minutes leave, and I have that many seconds. Does everybody see what I did? What I actually multiplied this by was a 1. That's just a 1, isn't it? Because 60 seconds equals 1 minute, 1 minute equals 60 seconds, so I can put it any way I want to, and it's always just a 1. And I can multiply anything by a 1, and it's still the same, quantity. Still has the same quantity. That's the word I'm looking for, right? Okay, does everybody see how that worked? Okay, now that would be converting. And it's harder in the English system because, like I just said, if we wanted to figure out how many inches there were in a mile, I bet you some of you know how many feet there are in a mile. How many feet are there in a mile? I think his hand went up first.
5,280.
Okay, there's 5,280 feet in a mile. Per mile, right? Per 1 mile. That's our 1, isn't it? So if somebody asked you how many inches were in a mile, you would take the feet in a mile, you go times line, because this is really this, right? I told you, whatever unit is here always goes down here. Don't even think about it. And then up here, you're going to put what you're looking for, which in this case is inches. How many inches are there in a foot? There's 12 inches in every 1 foot. That makes this a 1, doesn't it? This will cancel. You're going to multiply this by this. That's ugly, isn't it? That's going to give you some weird number that Calvin's going to give us. What's it going to give us, Calvin? Do you have it?
Yeah, 63,460.
63,460?
60, yeah.
Okay. And that's inches. Is that what you got too, Calvin?
Hold on, I have the plus sign to the left.
It's all right. This is hard, isn't it? I mean, in my opinion, this is hard. If you were going back and forth between cups and ounces or all of that, you've got all these weird numbers to deal with. Now, the reason I say that is with the metric system, what you do is you put prefixes in front of them, and they're all base 10, which means you're just dealing with zeros going back and forth. Okay? So look on page 11. On page 11, it gives you a bunch of them. The only ones you have to have memorized are the ones that are bolded. You have to have memorized milli, centi, and kilo. Let's start with kilo because it's the big one. If you put kilo in front of meters, so here's our meter. If you put kilo in front of that, a kilometer, 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 that's 1,000 of these. It means times 1,000. So a kilometer is if you go out and pace off 1,000 of these. that would be how long a kilometer is. I think there's a little over 2 kilometers in a mile. Okay? So it's a long way. I had a chemistry class once that just couldn't get this when I taught in a Christian school system. So I made them go out in the heat and walk off a kilometer. They remembered it after that. Okay? Now, that centi there, how many cents are there in a dollar? 100. How many years are there in a century? 100. Centi means 100th. There's 100 of them in this. And actually, those are the numbers on here. If you can see them, it's broken up into centimeters. Centimeters, there's 100 of them in the base unit. So that's just like a cent in a dollar, right? How many years are there in a millennium? 1,000. Very good. Excuse me. 1,000. There are 1,000 millimeters. That's the little lines cutting up these centimeters. There's 1,000 millimeters in 1 meter, just like there's 1,000 years in a millennium. Does that make sense to everybody? So all we're doing to get smaller or bigger is moving around zeros. We're dealing with tens, which is a lot easier to deal with. Okay? So if you were going to measure a person, you might measure that person in meters, or you might measure them in centimeters. If you were measuring a pencil, which one would you use? Meters or centimeters? Centimeters. If you were measuring how far it is to get home in the metric system, which would you use? Would you use meters, or what would you use? No, we're going to do it in the metric.
Kilometers.
Kilometers, good. I know, in you and I, because we're English thinking, we're thinking miles. But I'm trying to use this. So we would go to kilometers, very good, right? You've heard of a 10K run or whatever. They're doing 10 kilometers, okay? So you can see where you would use these different ones. What if I had a grain of rice and I wanted to measure the grain of rice? Would I use a meter? Would I use a kilometer? Would I use a centimeter, or would I use a millimeter?
Millimeter.
Probably a millimeter for grain of rice. Okay, do you see where this comes in handy? But they're real easy to convert between because you're just dealing with tens. Now with the liter, works the same way. If I have a kiloliter, is that going to fill this, or is that going to fill a hot tub? A kiloliter.
Hot tub.
Hot tub, very good, because kilo means times 1,000. So if I stood here and did this 1,000 times, I'd probably fill a hot tub, and that's a kiloliter, okay? Whereas this little guy, you've seen these before probably as homeschoolers, this little guy actually holds a milliliter of water. It actually does. It's a cubic centimeter. If this is a centimeter on one edge, and when you cube a centimeter, it holds a milliliter of water. There's actual logic behind this type of measurements, which I like. And so if I took this and I went like this, how many times would I have to do this little block to fill this thing if it's a milliliter?
1,000 times.
Very good. I'd have to do this 1,000 times for it to fill. And this little guy holds a centiliter. How many times would I have to do this? 100 times. I would have to do this 100 times to fill this up. Is everybody tracking on how this works? Okay? I don't have anything to show you on the grams. I'm sorry. I know. Give me $100 bills, and that would be... Okay, never mind. All right. Let's do the conversions in between. And so let's go over to page 14, please, where he gives us some examples. Okay. Now, I want to teach you a system of how I would like you to do these conversions. Everybody over on page 14? I'm going to show you how I would like for you to do these problems and how I would like for you to write them out. And I just started the chemistry class today, and those of them that had physical science with me, I smiled at them. I said, you remember times line? And they went, yeah. And I go, well, that's what you're going to be using all year. So it's really worth learning this because you will be using it for a long time. And I don't call it the factor label method, even though that's what it is. It has a more technical name. It's called dimensional analysis. And it sounds so much more cool when you say, please leave me alone. I'm doing my dimensional analysis. Everybody will be very impressed, okay? And the reason it's true is because dimensions are the units. Dimensional analysis is when you use the units to help you to figure things out about something. That's the analysis. Okay? Dimensional analysis. You're using the units to help you. And the units, guys, the units are our friends. We want to hug them and say, oh, nice units, because the units actually keep your numbers where they belong. And that's very important when you're doing these kind of problems. So let's look. On page 14, on your own, 1.3, it says, oh, sorry. What I want you to do when you do these problems is this. First, breathe. Do you ever hold your breath when you're tense? I do. I mean, literally sitting in traffic, my kids have heard me go, breathe. You know, okay? So first, breathe. Don't like pass out. I'll even write down the steps here. First, breathe. Okay. And the reason that's first is the next step's really more important, but if you pass out, then you can't do the next step. The next step is pray. Okay. Should always pray before you do your schoolwork. Don't pray after you take your test and say, please, Lord, let me have done well. Dumb. Excuse me. You pray before you study. You pray while you're learning. Then you pray before the test. Okay? I had a standard prayer in college. Lord, please help me to remember everything I've studied and learned and take a good educated guess on the rest. That was my standard prayer for every college test I ever took because I didn't have a lot of time. So that was my prayer. And I prayed before I studied. Because that was the time to pray. It's still the time I pray. When I'm prepping for your classes, I literally get on my face before the Lord. Because every Thursday is like an oral test for me. Okay? And so pray. Start there. All right, breathe, pray. Then you should read the problem twice. This works for any word problem. These first couple of steps works for any word problem. I don't know about you, but I never liked math word problems. How about you? No. And so this works for any word problem. You read the problem twice. You read the problem twice. I'm going to tell you why you read it twice. The first time you read it, you're letting your brain go, ah, I'm doing a word problem. Okay? That's what you're doing. All right, you're just, ah. Okay. Then you're breathing, you're praying. The second time you read it, you're going to read it and you're going to look for the given. You're going to look for the given and the get to. I know, really technical terminology here. You're looking for the given and the get to. So I'm going to put here, look. Because this is what you're finding, the given and the get to. Once your given will be a number with a unit usually, but it'll be something that's giving to you. So it's got numbers attached to it or something, okay? The get to is what they're looking for. Once you have that, you want to write down the given. And I personally like to put a question mark to the get to so I know where I'm going. But once you write down the given, if it's one of these conversions, the next thing you're going to do is after the given, you're going to go times line. Times line. And then whatever the given unit is, you're going to put it down here. Always, 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 always. Aren't you glad? The only other thing I know that's like that, it's actually more so, is Jesus. You know, he doesn't change, right? This is one of those things that you just, yay. If I'm doing a conversion, I always put that unit down there. I like stuff like that. I'm not saying that's like Jesus. Don't get me wrong. I'm not trying to pick, you know. But what I'm saying is I like it when things don't change. Like I'm never good at spelling because sometimes they don't make sense, right? How they spell things. And it's because our language is a mutt language that's made up of all sorts of other languages. So you never know how something's going to be spelled. At least when I finally learned that as a homeschool mom, I thought, wow, I wish somebody had told me that in school. Then I would have understood why I have so much trouble with this. That's why I'm a math and science person. The math is like very cut and dry. And I like that. I like things that are just cut and dry. You can do it a couple different ways, but as long as you're working the rules, it should come out. Right? Okay, so you do this. So let's try this. We're going to breathe, we're going to pray, we're going to look at 1.3, we're going to read it twice. First time, a student measures the mass of a book is 12,321 grams. What is the book's mass in kilograms? So first, I'm doing a word problem. Okay, now we're going to read it and look for the given and the get to, all right? The student measures the mass of a book, and I've got here the given, which is 12,321 grams. And what is the book's mass in kilograms? There's my given, and there's my get to. I got it. My given and my get to. It's right there, isn't it? The get to is where I'm trying to go. I'm going to write the given again. So I'm going to go, here we go. And I'm going to add to it, what am I adding? Times line. Everybody say times line. Times line. Okay. Now, what do I put down here? All you can tell me is the unit so far. What do I put down here? No, whatever's here.
Kilograms.
Good girl. Okay, grams. Thank you, ma'am. Whatever is here has to go down here so it'll cancel. Because remember, this is actually this, isn't it? Okay? And then I'm trying to get to kilograms. So that's going to go up here. Now, this is where I do it differently than the book. The book likes fractions within fractions, and I don't like fractions in fractions. So at this point, I ask myself, which guy is the big guy? A kilogram, which weighs like the mass of 2.5 sodas. If you had canned sodas, 2.5 canned sodas is the mass of a kilogram. And we said that a gram was the mass of a dollar bill. Which one is the heavier of the two? The kilogram is. So I'm going to give the kilogram a 1 because it's the bigger one. He does it the opposite, doesn't he? It drives me crazy. Decimals within a fraction, that's a fraction in a fraction. Ah! Okay, I just don't like that. You feel free. As long as your 1 is actually a 1 where it's equal top and bottom, you feel free. But this is how I like to do it. How many grams are there in a kilogram? Because we already said kilo means times 1,000. So how many grams are there in a kilogram? 1,000. So I'm going to put my 1,000 down here. Now this is a 1, isn't it? And I can multiply anything by a 1 and not lose its value. So I'm going to do this. And just in case you're not tracking with what I'm doing, this comes out over here 12,321. And if we carried these, it would be grams per grams kilogram. And so we are canceling these two because we end up having them top and bottom, don't we? Here and here. So we're getting rid of that here. And that gives us our answer, doesn't it? Now there's something else I want to make sure you know. Yes, Rachel? Oh, yes, ma'am. 1, 2, 3. Thank you very much. You're so kind. High five for the help. Yes. Okay. Thank you. And she did that so nicely. Yes, we have to move. And this is actually where I was going next. Thank you. If you have one top and bottom, you take whatever's on the top and divide it by what's on the bottom. How do I know that? Because this line means divided by. So in your calculator, you would put 12,321 divided by 1,000. And what number comes out goes here. The grams cancel, and you're left with the kilograms, and that goes there. Does everybody see that? If the two numbers were on the top, you would multiply them. But here, one's on the top, one's on the bottom, so you're going to take the first number and divide it by this number under here. Is that clear? Okay, let's try the next one. Thank you for the help, Rachel. That was great. Long day. Okay, the next one, 1.4. If a glass contains 0.121 liters of milk, what is the volume in milliliters? So we have 0.121 liters of milk, and we want to know how many milliliters that is. I got the given, I got the get to. I have read this twice. As a matter of fact, I've read it a whole lot more than that, so you forgive me if I went ahead and did that, okay? Now we're going to write the given again. That was the next step. Class, what am I going to write now? Times line, thank you. Let's all say it. Times line, thank you. We're going to do times line. What unit do I put down here?
Liters.
Liters. What unit do I put up here? Milliliters. Now I need to make it a 1. But I want to give the big guy the 1. Which one's bigger?
Liters.
Liters. So I'm going to give him the 1. How many of these do I have to do to get in here? 1,000. Okay. Then I'm going to multiply these because they're both on the top. So this time it's going to move my decimal back 3. Just use your calculator so you don't mess up like I did. It moves it, right, because I'm multiplying by 1,000. So it moves that. The liters cancel because I have one on the top and one on the bottom, and I'm left with milliliters. So there's my answer. In this case, they're both on the top, so you're going to multiply them. If it was down here, you'd be dividing it. Okay? All right, let's try the next one. The next one, it says if the National Basketball Association, the distance to the three-point line in basketball is 723.9 centimeters to the top of the arch. What is the distance in meters? So here we're looking for meters. So I'm going to write this again. This is what I want to see on your paper, guys, so make sure this is what you have. Whole class, what do I write next? Everybody. Come on, everybody. Times line. Okay, good. All right, what goes down here? Everybody, what unit goes down here? Centimeters, because that's what is here. What goes up here? Meters. Which one is the big boy? Which one is the big boy? Meters, because centimeters are these little guys, okay? So we're going to give this one the 1, and the centimeters, there's 100 of them, like 100 cents in a dollar. Are we going to multiply these numbers or divide this time? Divide. We're going to put this in, divided by 100. This is going to cancel, and we're going to be left with 7.239 meters. Right? How are we doing with that? So far, so good? Okay, and then it doesn't change when we convert between the English and the metric, and you will not have to memorize these. They will give you the equalities, the bridges, to make the funky ones, so don't worry about that. What you need to memorize is kilos times 1,000, centi, it means 1/100th, and milli means 1/1000th, okay? You have to know that. You have to know that mass is measured in grams, the base units. And that in the English it's slugs. You have to know that distance is measured in meters in the metric and feet in the English. You have to know that volume is measured in liters in the metric and gallons in the English, okay? And seconds for time. But let's look over, okay, right under that on page 14, you see table 1.3? It gives you the relationships between the English and the metric units. And see, 1 inch is equal to 2.54 centimeters. You guys all see that? You don't have to memorize this, but you have to be able to use it. Let me show you how. It's the same thing. Over on page 15, 1.6. A piece of yarn is 3 inches long. So that's our given, 3 inches. We want to know how long it is in centimeters. So that's my get to. I do the same thing again. I write the given again. What do I write next, class? Everybody together. Times line.
Why are you keeping the 2 zeros?
Because it was given. So I'm writing it down.
Okay.
Don't worry about it. I just did what they did, so it's all good. What goes down here? What is the unit? Inches. And what am I trying to get to? Centimeters. Okay, so that's my given unit down here, my get to up here. Now I look on the chart. And this is important because I've seen students mess this up. Because remember, I don't know if I told you this. I used to teach at the Christian school. And I use these textbooks. I've seen the mistakes. So I'm going to tell you what not to do. No, I'm going to tell you what to do. How's that? What number is next to the the inch on the table? What number is next to inches on the table? Look on the table, table 1.3. What number is next in front of inch? No, in front of inch.
1.
1. Write it in front of inch here. What number is in front of centimeters on the table?
2.54.
Put it in front of the centimeters here. People get them confused. There's no reason. Whatever it's written there, whatever it's in front of there, you put it that way here. Okay? Am I going to multiply or divide these two numbers?
Multiply.
I'm going to multiply these two numbers. Inches is going to leave, and somebody with a calculator, what do we get?
7.62.
7.62 centimeters. Thank you, ma'am. That's how that works. Let's do the next one. How many slugs are there? I'm going to erase this, guys. How many slugs are there in 12 kilograms? So here's my 12 kilograms, question mark slugs. There's my given and my get to. I write my given again, 12 kilograms. Class, what do I write next? Times line. What goes down here? What unit goes down here? Kilograms. Because that's here, it's got to go down there. Does everybody see that? What unit's got to go up here? Slugs, because that's what I'm looking for, correct? Now I look at the chart. What number is to the left of slugs on that chart? 1. So it's going to go to the left of it here. What number is to the left of kilograms on that chart? 14.59, and it's going to go there. Does everybody see how that works? Now the kilograms will leave. Am I going to multiply these two numbers or divide them? Divide. I'm going to put in my calculator. 12 divided by 14.59, and Molly's going to tell me what that is.
It's 0.82.
0.82. I'm good with that. Slugs. Your hand was up. Oh, good girl. Okay. You have it already. Good girl. Oh, if you get some wild number with lots of decimal places, just cut it off and round. Okay, let's do the last one. Okay, the last one here, 1.8. An object is 3.2 gallons. And how many liters of space does that take up? There it is, our given and our get to. We write the given again. Times line, right? Everybody say it. Times line. Okay, what unit goes down here? Gallons. What unit goes up here? Liters. Very good. Look at the chart. What is to the left of liters? What's to the left of liters there? So I'm going to put it to the left of it here. What is to the left of gallons there?
1.
So I'm going to put it to the left of gallons here. Am I going to multiply these two numbers or divide them?
Multiply.
I'm going to multiply these two numbers because they're both over the top, right? Gallons going to cancel, because remember this is this. Gallons going to cancel, and I'm going to get 9 something?
12.384.
12.384. I should have known that because that's almost 4, isn't it? Right? So that'd be 4 times 3. That's close to 12. Okay, liters. So you see how that works? Yes.
I got a different answer than she did.
What'd you get?
I got 12.0.
Oh, you know what? I'm not even worried about it. If you got 12 and you put liters, it'll be right. Okay? Remember, thank you. That was so sweet. But this is not the math class. If you got all this written, you know what? If you've got all this written down and your answer's wrong, but you have this here, I'm going to give you most of the credit because you're showing me you know what you're doing. Does everybody understand that? So how important is it that you write everything out? Very important. How you doing? You okay? Whew. First day. We got it. Snoopy dance. Okay. How did Jesus fill the week, you guys? Any questions? You good?